Hi everyone, this is the Trig lesson 3.1 for radian measure. So we learned about radians a little bit last year in Algebra 2, so we're just going to expand that a little bit. So 1 radian is the angle measure that's equal to, when we have the arc length equal to the radius. So that means we would have 1 radian if those lengths are the same. So the main big idea here is that a complete revolution around our circle is 360, and that would be 2 pi in radians. So that's how radians and degrees are equivalent. Usually when we have radians, we have the pi with it, but sometimes they multiply that out, so we could just have a decimal number. The big difference is that when we have degrees, we always put the degree symbol, but with radians, we don't. So if there's no degree symbol, it's assumed that that number means radians. So let's talk a little bit about how we convert between the two. So since 2 pi is equal to 360, that means pi would be equal to 180. So to convert back and forth, we use that ratio. So to get from radians into degrees, we have to cancel out the radians. So we kind of put that pi in the bottom and then our degrees on top. So we would multiply by 180 over pi. But to go from degrees to radians, we have to cancel out the degrees. So we put the degrees on bottom and the pi on top. So let's try our first example. So it says to convert that measure to degrees. So if we're converting 2 degrees, pi goes on bottom, degrees on top. So what we want is on top. And then we can just times straight across. The pi's are going to cancel out. When I do it, I like to reduce my numbers beforehand, but you could just multiply straight across and then try to reduce after. I know that 4 can go into 180 45 times, so I can cancel that out and change that to a 45. And then I would just have 9 times 45, which is 405. So 9 pi over 4 is equivalent to 405 degrees. Okay, so let's try another one. To convert to degrees, we multiply by 180 over pi. So again, you could just times straight across and then divide afterwards, or you can cross reduce like I did on the first one. If we times straight across on this one, 5 times 180 is 900, so we would have negative 900 over 6. And then if we divide that, we get negative 150 degrees. Okay, so you can do either method, whatever way you like simplifying those fractions better. So why don't you pause your video and try examples 3 and 4. I know you're kind of scared of that one because you don't see the pi symbol, but it's the same thing. So we end up with the pi in the denominator, and then use the pi button when you're dividing that out. So pause, and when you come back, I will show you the answers. Okay, so let's take a look. So like I said, for question 3, we just times straight across. So we'd have 765 over pi, and then I use the pi button to get that decimal approximation. So 243.5071 degrees. Number 4 was just like 1 and 2. So we ended up with 165 degrees. Okay, so let's try to convert the other way. So let's start with degrees and go to radians. So for these, we multiply by pi over 180. The thing we want in the top and the thing we're canceling out in the bottom, because remember, those will cancel out. So if we multiply straight across, we end up with 45 pi over 180. And we always want to reduce our fractions. So we know that you can divide both of those by 45. So we end up with pi over 4. Okay, so let's do one more, I guess. So times by pi over 180. So negative 270 pi over 180. And reduce your fractions. You can divide by 10 to cancel those out. And then in 27 and 18 can be reduced by 9. So we end up with negative 3 pi over 2. So 270 degrees is negative 3 pi over 2. Okay, so go ahead and pause again and try examples 3 and 4. For example 3, I simplified my fraction, but that's because the calculator did it for me. But you can leave your answer as a decimal, so multiply that pi out. Okay, so for number 3, we end up with 3 pi over 5. And then number 4, here's the reduced fraction, which is like ridiculous. So that ended up being 4.3598 radians. Okay, so we're going to do a couple more examples. They're not in your foldable, so we're just going to use the space below where we would glue this down on our page. If you don't know what I'm talking about, you can just write it on a separate paper and I'll show you like where to put it in your notebook, or you can write it at the top of your page and glue your foldable below it. It doesn't matter. So for these, it says to find each function value. So we're doing what we did last chapter, but we're doing it now in terms of our radians with our pi's. So once we get our unit circle straight, it might be easy, like you could just leave it in radians, but for now, we kind of don't know like what 2 pi over 3 actually equals. So the method to go from here would be to convert your radians that you have here into degrees, and then do what we learned in chapter 2 and draw those degrees on the coordinate plane and see what your reference angle is and stuff. So first we'll convert 2 pi over 3 to degrees. So that's using the method we just used, so times by 180 over pi. I'm just going to simplify it all for you, so we end up with 120 degrees. So that means that this tangent of 2 pi over 3 is equal to the tangent of 120 degrees. So using our skills that we learned in chapter 2, we'll draw our triangle. 120 degrees is here, so that means we have a reference angle of 60. And then build your special right triangle from what we learned in chapter 2. So across from 60 is root 3, hypotenuse is 2, and then the adjacent side is -1. So they wanted us to evaluate the tangent of that. So in our picture we get root 3 over -1. So the tangent of 2 pi over 3 is equal to negative square root of 3, because this is equal to 120. Okay, so why don't you pause your videos and try those other 2 examples, and when you come back we'll talk through the answers. Okay, so here is an example of how I set up my notebook from last year. So we have our foldable at the top, and then those examples written at the bottom. So let's take a look at those other 2 examples. So the sine of 2 pi or 3 pi over 2, 3 pi over 2 ends up being 270. So the sine of 270. And remember, that's one of our quadrantal angles. So we can just use the ordered pair. So sine is the y coordinate. So that's where we got our -1 from. Okay, so with our cosine of -4 pi over 3, 4 pi over 3 ends up being 240. So the cosine of -240 would be the same as the cosine of 120. So 120 is the picture we drew for our first example. So what would be the cosine of this triangle that we drew for the first? And that's how we got the -1/2. Okay, so make sure you write down any questions you have on this, and we will go over anything next class. So that's it for 3.1. Werner out.